redundant, a little bit repetitive, but I'm just gonna roll back here. I think this will make a little bit more, there'll be a little more continuity if I kind of start over now. I know I've cheated a little, I've come up with the game plan, but this will help me when I go to export this as its own standalone video. So here we go. We're going to be doing this challenge now using SolidWorks, doing some live modeling here using SolidWorks, and this is the challenge that we're going to create. And unlike most of our live challenges, this one is an assembly, essentially. It's a shelf. It's a 1 meter tall shelf. It's got shelf unit. It's got 4 shelves on it, and it's got a set of angled legs that are running up the side. And so what we always teach our students when we're modeling, when we're doing 3D modeling, is before you get started, you want to come up with a game plan. You want to ask yourself, how am I going to model each of these legs? How am I going to model the shelf? How am I going to model this little notch here in the shelf so that it perfectly matches up with those 4 legs? And I think that in the case of this model, I'm going to use a single part file, and I'm going to do what's called multi-body design. And this leg here that I've circled, I'm going to create that as my first body in this multi-body design. So I'm going to create a sketch here on the front plane that represents the shape of that leg. And then I'm going to extrude that sketch out to a depth of 30 millimeters. And I'm going to use the option for offset sketch plane to offset that sketch plane to 330, over 2, 1/2 of 330. That's going to give me my first leg. Then I'll be able to do some mirroring with that leg. So I'll mirror the leg over here, and I'll mirror those 2 legs over here. And then I'll have all 4 of those legs. And then I think what I'm going to do is I'm going to create a sketch of the shelf by just making a rectangle here at 50 millimeters high. And then I'm going to do a really cool pattern. And this pattern is called a linear pattern using the variable distance option. So a linear pattern with the variable distance option, and I'm going to say that I want this first instance to be 350, the second instance to be 200, and the third instance to be 100. And I think for each of them, I'm going to have to add the 50 millimeter for the shelf thickness. And that should get me pretty close to the end of the model. Then I'm going to come up with the challenge of, well, how am I going to notch out these corners? How do I notch out these corners here? And I think what I'm going to use for that is actually going to be a little bit of surfacing. Mix it up a little bit and use a little bit of surfacing. So I'm going to make a little surface there on that leg. I'm going to extend that surface, and then I can use that surface to do a cut. And I can cut through those shelves using that surface. Maybe I'll make a mirror of that surface as well so that I can get all 4 of them at once and then make a cut of that shelf in the corner. There's lots of different ways you can do this. I know in the chat, Aaron was saying that he did it using an indent command in the corners. You could maybe make it as an assembly. Lots of different ways to do this, but the main thing you want to take away is to always come up with a game plan before you get started with your model. So now that I've got that game plan, let's go into the Windows snipping tool. I'm going to grab a screen capture of this model. I'm going to move this model over, or this screen capture over onto my second monitor. And I'm going to begin modeling this. And as you guys know, when I start modeling, I get really zoned into the modeling. So I'm probably not going to react to the chat too much. But if anything really important comes up in the chat, I'll still kind of keep an eye on it so I can answer your questions. So let's go in here. Let's start a new part here in SolidWorks 2015, my favorite build of SolidWorks. I'm going to make this a part using millimeters. And to stick to the game plan, I'm going to start out on the front plane, begin a sketch, and I'm going to create a sketch here with a center line. And I'll say that that center line is going to be used to drive the location of this set of angled lines here. Now, one thing that you can do when you're sketching in SolidWorks, if for some reason you don't pick up on the parallel relationship, so you can see the relationship there showing up as parallel, it's in yellow, so that means this will add the relationship of parallel there. I'm going to delete that. I'm going to delete that line, and I'm going to recreate a line here. So here's the line. And if for some reason you ever don't get that relationship to show up, you can just hold your mouse over that other line for a moment, and then you move back over, and then that'll kind of like reactivate the relationship to that line. So if you ever find yourself in that spot, that's kind of like a pro tip that you can use to make sure that you kind of reactivate that relationship capability for that automatic relationship. Now, this is going to have a distance to the outside of 360. So the way that I'm doing that is I'm using what's called a doubled dimension in SolidWorks. So I pick this point, pick this line, come across, and then I make that 360. And then SolidWorks does what's called auto scaling. See, a moment ago, before I did that, that dimension was 81. And it almost looks like the screen doesn't change at all when I change that to 360. But that's because when you put in your very first dimension, SolidWorks does this really cool thing where it automatically upscales the entire sketch to match whatever the value of that first dimension is. So auto scaling on that first dimension, very cool functionality in SolidWorks 2015. Now, what I'm going to do after this is I'm going to create a another dimension here, which represents the width of this thing. So this is going to be kind of on an angle here. That width is going to be at 30 millimeters. And then there's going to be a dimension here, which represents the height of this thing. So the height is going to be 1 meter. And then finally, what I'm going to do is I'm going to indicate an angle dimension here, and the angle dimension from here to this line and then crossing over that line is supposed to be 8 degrees. So the way that we get those double dimensions when we're doing an angle is you hold shift. When it's a linear dimension, it happens automatically, but when it's an angle dimension, you have to hold shift. So we're going to hold shift there. We're going to make that a dimension of 8 degrees. And there we go. That sketch is all black, which means it's fully defined, fully constrained. And now we're ready to go into an extrude command. And this thing is going to have a depth of 30 millimeters, but it's not going to be 30 millimeters from the front plane. It's going to be 30 millimeters offset. So I'll use this flyout menu here to make this offset. And that offset distance there from that flyout, we fly out this menu here, offset, that offset distance is going to be 330 over 2. 330 over 2. And then we can examine the extrusion direction here, flip the direction if we need to, because it's going to be 330 over 2 and then going inward, or this way, inward. It's going to be going inward. So make sure that the direction of that extrusion is correct. And there we go. Now we've got that leg extruded in the correct direction. Now this leg is supposed to be hollow, so I think the next thing I'll do is drive a shell in here that's going to have a 5 millimeter wall thickness, and that shell is going to be applied here on this leg and on this leg here. And so we hit the green check mark, and there we go. That gives us our first feature there in the tree, that that leg. Now, I'm just going to show the front and the right plane here just so you can kind of see what our plan is. Our plan next is to mirror that leg about both of these planes here. And we're not going to be doing this as a mirror feature. We're not going to go in here and say mirror and then choose a feature to mirror. We're going to go down here to bodies to mirror. So right now, currently, you can see that the selection box is on features to mirror. Well, here's a pretty cool thing that I learned. Believe it or not, I learned this from Aaron C. in the chat, but just kind of through osmosis or through like a different conversation we were having about a custom macro that he was working on. Check this out. If you go into the solid bodies folder here in SolidWorks and you pre-select a body and then you pre-select a plane, what SolidWorks will do is when you go to the mirror command, SolidWorks will automatically use the bodies to mirror field in that box. So normally when you go into the mirror command, you can choose features to mirror or faces to mirror or bodies to mirror. Well, if you do this, pick this body, then hold control, then pick a plane, then let go of control and then choose mirror, SolidWorks automatically does bodies to mirror here. And so if you take that one step further and you use the power move that I posted a couple of weeks ago where you modify the context menu so that mirror is right here, then what you can do is pick the body, hold control, pick the plane, let go of control, mirror, and then just hit the green check mark, and you will have your mirrored body here. And so we can do it again here. We can hold control, pick these two bodies, pick the right plane, let go of control, mirror, and then hit the green check mark, and boom, we're done with those mirrors. So it's all really out of the box functionality. The only thing I really did to customize it was just modify this toolbar. But even if you didn't have this toolbar, you could just click here, mirror, and then you could right mouse button to finish. Keeps going merge solids for some reason on the first one because it's not multi-body yet. But once it's multi-body, then it'll just kind of happen automatically. So we pick these two here, pick mirror, and then just come out here and right click. Boom, we're done with mirroring those bodies. So that's something new that I discovered and that I've been using a lot lately is pre-selecting a body from the tree and then choosing mirror. And that way it automates the process of selecting the bodies to mirror. Nice little extra pro move there in this example. All right, all of these legs are made from the same material. That material is 1060 alloy. So I'm just going to make the whole part out of 1060 alloy. So here we go, 1060 alloy for that whole part. And then I'll make the I'll make the shelves out of a different material. So now for the shelves, I'm going to go front plane, begin a sketch, orient my view. Now the way I originally did this was I created the shelves individually using rectangles. So I did it like this. I made this 50, enter, let's say like 300, just something that's enough that it'll be sticking off the ends here. Let's make it 500. So I did it like this. And then I included a vertical point here. So I could take this point here, make it vertical. And then I took that geometry window, select, hold control, drag and drop, and then repeat, drag and drop, and then repeat, drag and drop. Make all these points here vertical, and then add the dimensions between them. The nice thing about that is that it makes it pretty easy to align the top shelf here to this top segment. But I'm going to show you today a different way of doing this. So that's totally valid. You could totally do it that way and then use the remaining steps that I'm about to show you. But a different way that you could do this is you could create the dimension for the first shelf here from the bottom. So this is going to have a dimension here of 150. So we'll go from the origin there to that first shelf, and we'll make that 150. And then we can take that geometry and we can extrude that. So we're going to extrude that, and let's make that to the same, up to face and up to face. So I'll double click this face here. So there it goes, up to face. And then for direction 2, I'm going to choose up to face as well. And currently that is merged. That's not what we want. So I'm going to edit this feature here, and I'm going to say, don't merge the results. Now, here's another kind of cool trick that you can do if you're ever working in SolidWorks on multi-body. You can see here that when I'm in the sketch and I go to take that sketch and extrude it out, the default behavior is that merge results is selected. When you're doing multi-body or when you're doing a single body, it always defaults to merge result. Well, the quick way to get that to not be selected is you can go up here into weldments and you can say, weldment. You can just click this button here that says weldment. So let me get out of the sketch. And now I'm going to go up here and I'm just going to click this button that says weldment. So I'm on the weldments toolbar here. Weldments. And then I'm going to click this button here that says weldment. And that's it. I'm just going to click the button. It adds a new feature in the tree. It changes this to be a cut list, which means that it'll group together items that are identical. But what it also does is now when I go to this sketch and go to extrude it, merge result is not selected by default. So if you know that you're working in a model that's multi-body, it doesn't have to be a weldment. It could be a plastic enclosure for remote control that has a bunch of buttons on it and you're just designing it all in one part using multi-body. Well, if you just click the weldments command and add that weldment feature here at the top of the tree, then merge results will no longer be selected by default, and that can be a nice time saver. So now we'll go extrude. We'll double click on this face here so that we go up to that face. For direction 2, we choose up to face, and we're going to click on this face back here for direction 2. And there we go. We hit the check mark, and now that is not a merged result. And this shelf is going to be made out of a different material. This is going to be made out of ABS. So I'm going to go to that shelf, right mouse button on the body, and choose material, and then I'll change that to ABS. And so now the way these are listed is a little bit different. These 4 are identical bodies. All 4 of them are identical. So it's one item, one drawing, one SKU with a quantity of 4. And then this one has a different SKU, and this one also has its own material, so the material is listed down below. These bodies here are all using this material, the material of the part. This body here is using a different material. It's using this ABS. And so now I'm going to take that body and I'm going to choose to create a linear pattern from that body or from that feature. So I go linear pattern here, and I'm going to say that the linear pattern is going to use this dimension to drive the direction of the pattern. This is just something kind of cool that you can do with linear patterns. You can use a dimension to drive the direction of the pattern. And then for the spacing, I'm going to say that spacing is going to be 350. So there's the spacing of that pattern. There's 4 instances of that pattern. And that looks okay. It's certainly the first one looks good, but the remaining shelf is supposed to be 200, and then the final shelf is supposed to be 100 for the spacing. And so what I'm going to do is I'm going to go down here to the very bottom of the linear pattern command, and down at the very bottom, there's this option for instances to vary. And I can choose that option for instances to vary. And then what I can do here is for each of these instances, I can click on this little magenta dot and I can say modify instance. So this one is going to have a spacing of not 350, but it's going to have or really it tells you what the total calculation is. So it's like 350 plus 350 gets you to 700. So it's going to be 350 plus 200 to get me to that instance. And then I'm going to do the same thing here. I'll say modify instance, and this one is going to be 350 plus 200 plus 100. I think, yeah, you know what? I needed to add that extra 50 in there. So we'll modify this instance and make that plus 50 or 600. And then we'll modify this instance. And this one is going to be plus 100. So this is going to be 750. 750. Oh, I guess actually, you know, this first distance here actually was wrong also, right? Because it's 350 plus 50. So, all right, it's fine. So this is going to be plus 50 as well. So 350 plus 50. So 400. This one is going to be 650. And then this one is going to be, I'm just adding the 50 here. Make that one 800. Whoops, 800. There we go. So that gives us the spacing using a different technique. When we did the, when we do, you know, the linear pattern using the modified spacing option, we can get that same spacing. This seems to me like it's a little bit cumbersome. You know, you saw there as I was going through, I was kind of, you know, doing some extra steps that I probably would not have done in the actual live model. I think I would have just used the technique I showed you initially, but this is meant to be kind of a tutorial, a live solve, and I wanted to just show you some other functionality. To date, when we've talked about this option of modify instances, what we've really talked about is modifying like the width of those shelves at the higher level, modifying a dimension from the sketch, but you can also modify these instances and change the spacing of the linear pattern in those modified instances. And that's really what I wanted to show off in today's demonstration. So now we get to kind of the final phase of this design. And for me, I think that what I'm going to do here is I'm going to use a surface command to create the geometry that I can use to cut these shelves. And so that surface command is very, it's something that I'm very comfortable using. If you're not using surfacing a lot, then this might be a little bit too exotic for you. But the way that I would do it is I would go surfaces and I would say offset surface, and I'm going to offset this surface at 0. And what I'm going to offset is going to be this face here on the back of that leg and this face here on the kind of inside of that leg. And once I offset those two faces, I can hit the green check mark here. And what I'm left with, I'm going to hide this body here. I'm going to hide that body. What I'm left with here is a surface here and a surface here that I can use to cut. The problem is that this surface here isn't long enough to do that cut. So I need to do what's called a surface extend. So I would do an extend surface here and maybe bring this out, say 100, 150 millimeters, whatever I need to get that surface to be out far enough, maybe even 200 millimeters, something like that. And now that I've got that surface extended out, now I've got enough room on that surface to cut these shelves. So what I would do here is I would probably hide these remaining legs just to make it a little easier to see. I would use the trick that we talked about earlier, pick the body from the tree, hold control, pick the plane, let go of control, mirror, right mouse button to finish that, and then pick the two bodies there, the two surface bodies, pick the right plane here, or I'm sorry, the front plane here, let go of control, mirror, and then right mouse button to finish that. And now I can jump into the command cut with surface. So insert, cut with surface, insert, cut with surface, or here, cut with surface. Then you pick your surface that you're going to be cutting with, and then you pick the body or bodies that you're going to be cutting through. So I'm going to be cutting through these bodies here. And now I've removed that corner, and then I can just repeat. So cut with surface. I'm going to pick this surface here. Usually if you do auto select, it's actually based on hide show visibility. So if I hit the green check mark here, it'll probably only cut these and not cut the leg that was there. So that leg is probably still there. Yep, I can see it's still there in the preview. So it's usually just based on hide show. If it's shown and it's in, interfering with that surface, then that body will be selected. So instead of needing to go, pick which bodies, instead of needing to pick these 1, 2, 3, 4 bodies, what I could do is I could say cut with surface, and then I could say auto select. And since these 4 bodies here are shown, and since they're being intersected by that surface, they're just automatically selected. Now, the final thing I'm going to do here is pick all these surface bodies and use the command insert features, delete bodies, delete keep bodies. But the shortcut to that is if you pick a body from the body folder and you press delete, then those bodies are selected and a new feature is created down here at the bottom of the tree called delete body, or body delete / keep. So now those bodies are gone. Now I can bring back these bodies here. These guys here didn't get the custom material, so let's make sure that they all have ABS as well. So ABS, ABS, ABS. So all 4 of the shelves here have ABS, and the legs have that 1060. And now the final thing I need to do is just kind of clean up the shelves there on the outside, because they're obviously sticking out too far. Although I kind of like that design more for the shelves. I think I would actually prefer something like this in my living room. But what we could do for that is we could just begin a sketch, convert entity. Really, we could convert up here too, but it's fine. Convert entity, and convert entity. So I just did a hold control and picked all 4 of them, bring these 2 lines together to kind of close that thing off. And then we could do an extrude cut. So S key extrude cut, right mouse button through all, and then we're going to do flip side to cut. So instead of cutting to the inside, it's going to cut to the outside. And once again, our feature scope here says which bodies are going to be affected by this. Well, we can do auto select because the shelves are shown and only the shelves are going to be affected. The legs are not going to be affected by this cut extrude. So when we hit the green check mark, there we see that only the shelves were affected, the legs were not affected. And so now at this point, we can do a Control Q to rebuild. And if we had our template set up with a sensor, we could just go up here and look at the sensor. But if not, we can add a new sensor, or we could go to mass properties. Either way, we can see that the mass of this thing is 22.91 kilograms. So let's see if that is correct. And that is correct, 22.9 kilograms. So we did it. We modeled this thing up using multi-body design in SolidWorks. And if you enjoyed that live solve, if you enjoyed that tutorial, be sure to hit the like button. Be sure to subscribe to this channel. There was a lot of good tips and tricks there on working with multi-body, and hopefully you can enjoy them in the future of your SolidWorks usage. And that is our live solve. Let's move on now in this presentation. Just gonna kind of take a look here at the chat, see if anything came up, some discussion here of